second method for solving systems of equations is called substitution. We've done substitution. You substitute in 4 every time you see x. We've done it a million times. The basic idea of systems with substitution is you got to get one of the equations, you got to get one of the letters all by itself. So if you look at number 1, easy. Y is already by itself in the top equation. And it could be either equation, but you want x or y by itself. So now we're going to take what y equals, x plus 11, and anytime in the other equation I see a y, I'm going to substitute in x plus 11. Here's the only y, so that's where it's going to go. When you do substitution, it's a good idea to put it in parentheses. So 5x minus the new y, x plus 11, equals negative 51. The reason we do that is because now our equation has all x's or all y's, and we can solve equations where it's all one variable. We've been doing that for years. So here we can distribute the negative 1. Negative 1 times x is negative 1x. Negative 1 times 11 is negative 11. All right. We combine our like terms. 5x minus 1x is 4x. 4x minus 11 equals negative 51. Now it's a two-step equation, baby. Add 11 to both sides. 4x equals negative 40. What are you going to do to both sides? You're going to divide by 4 on both sides. X equals negative 10. Perfect. Now we are looking for coordinates. That's half of our coordinate. How in the world could we figure out y? You substitute it back into one of the equations and solve for y. It doesn't matter which equation you use. So my recommendation is always pick which one looks easier to you. To me, the first equation looks easier to work with. Y equals x, and we know that x is negative 10 plus 11. Oh my gosh, negative 10 plus 11, that's 1. And remember with systems, when we were graphing, we wrote the coordinates. Same thing here. Write this as a coordinate. Negative 10, 1. So get an x or y by itself, substitute it in the other equation. If you look at example 2 here, the first equation already has x all by itself. So when I see an x in the second equation, right here, in parentheses, I can substitute 6y minus 8. So we'll have 2 parentheses, 6y minus 8 minus 12y equals 5. All I did to that second equation was substitute in for that x. Everything else is the same. So we distribute, gives us 12y minus 16 minus 12y equals 5. And we combine our like terms. 12y minus 12y, boy, let's cancel out. So we're left with negative 16 equals 5. Does negative 16 equal 5? No, it doesn't. So this is probably one of those special ones. No solution or IMS. No, that's not true. Negative 16 does not equal 5, so that would be our no solution. If everything cancels out and you're left with 5 equals 5, sure, IMS. But that's only if all the x's or all the y's cancel out. So let's try 2 more. Number 3, y equals. Again, we didn't have to even adjust anything. We already have x or y by itself. Sometimes you might need to scooch an equation around a little bit. But this is y, and it's going to go right in there behind that 2. So 3x plus 2 of these equals 48. Ooh, I'm glad I picked this one. If we distribute that, 2 times 3 is 6, so we'll have 6 over 4x. 2 times 6 is 12. Alright. If you want, you can turn that into a decimal. Otherwise, you can simplify it. It'd be 3 over 2. And you guys are so smart. You have the ability to clear out fractions. All you have to do is multiply the whole equation by a common denominator. Here, I'll rewrite it for a second. 3x plus 3 over 2x plus 12 2 times 3 over 2. 2 times 3 is 6, divided by 2 is 3. 2 times 12 is 24, and 2 times 48 is 96. Alright, cool. Let's combine some like terms. 6x plus 3x is 9x. 9x plus 24 equals 96. We could subtract 24 from both sides. 9x equals 72. Now we divide by the 9, and we got 8 for x. Cool. Again, that's just one of the two coordinates we need. So it'll be 8 something. We need to figure out why. You can use either equation. I'm going to use the first one because I'm a rebel like that. Y equals 3/4 x, which is 8, plus 6. Okay. So when you do fraction times a whole number, remember you just multiply the whole number up top. 8 times 3 is 24 over 4 plus 6. 24 divided by 4 is 6 plus 6. Y equals 12. Wowza. So our coordinate, the x was 8, the y was 12. That was brutal. And the reason I like this better than graphing is like, if one of those answers was 8.2, you wouldn't be able to tell that on a graph. So this is like, I think, a more exact way to figure out the answers. All right, number 4. I have x equals. Great. So now in the other equation, when I see x, I could replace it with 5y plus 2. So we'll have 3 times 5y plus 2. Then we got minus 15y equals 6. We'll go ahead and distribute. That will give us 15y plus 6 minus 15y equals 6. You know darn well we're going to combine our like terms. 15y minus 15. Oh no, cancels out again. We got 6 equals 6. That's true. 6 does equal 6. So that's our other goofy one, IMS, which again means infinitely many solutions. If we were to graph these two lines, they would perfectly overlap each other, and there would be infinite decimal answers that show up on both lines there. Look at that. Substitution.